work function of a metal surface. So work function is just we can say it's a minimum energy required for the electron emission from the metal surface is called what? It's a work function. So from this, the work function is defined like this: some amount of energy is required for the electron for its emission. So this amount of energy is needed, okay, but how this energy is supplied? So based on the energy supplied. So there are three types of emissions are there. So these three means what? Including photoelectric emission, there are four types of emissions are here. One is, for the very first one, thermionic emission. It's a thermionic emission. First one is thermionic emission, and the second one is field emission. It's a field emission. And next one is, it's a photoelectric emission. And last one is secondary emission. It's a secondary emission. Let us discuss. So what about these types of energies supplied for the ejection of electrons? So very first one is thermionic emission. Means thermionic emission by giving some thermal energy, so this thermionic emission is possible. And next one is field emission. Field emission is what? It's a surface, means what? By changing of electric field, continuously by changing electric field, strong electric field we can say it. And photoelectric emission, this is by electromagnetic radiation. And secondary emission, so we can say this is what? When fastly moving electrons collide with metal, then what happen? This energy can be transferred to the metal surface, and electrons acquired the energy, then they can eject from the surface. So that is what? Secondary emission. So let us discuss photoelectric effect, which is very important. Direct question will be asking from this area. What is photoelectric effect? Okay, so first one is, it's a photoelectric effect. From photoelectric effect is a phenomenon. Just we can say it is a phenomenon. a phenomenon so of emission of electrons, emission of electrons, emission of electrons from metal surface, from metal surface, emission of electrons from metal surface. So by using or by the use of light or light energy, by the use of light energy with a suitable frequency, with suitable frequency or wavelength, suitable frequency or wavelength, so is called, it's a photoelectric effect, photoelectric effect. So in this photoelectric effect, just to escape the electrons from the surface of metal, so photoelectric effect is this amount of energy is given, that energy in the form of light. So it's based on this very first condition about work function or threshold energy, so which already we completed. The terms which we need to use here, first one is work function. It's a work function. So work function is W naught, which is known as threshold energy. It's a threshold energy. It's a threshold energy. And the second one is threshold frequency. Second one is threshold frequency. First one, let us go for this work function. W naught, just let me complete this. So first one, W naught. W naught is equals to H nu naught. Nu naught is what? It's a threshold frequency. Threshold frequency. And we can also write W naught is equals to Hc by lambda naught. This lambda naught is called threshold wavelength. Threshold wavelength. So it's a threshold wavelength. Okay. So now we can say the work function W naught is equals to, first one is H nu naught, or W naught is equals to Hc by lambda naught. Nu naught is threshold frequency. Lambda naught is what? Threshold wavelength. So let us discuss about. So first one, this is work function is completed. And next one, it's a threshold frequency. Threshold frequency is the minimum frequency of incident radiation. It is the minimum frequency of incident radiation. Minimum frequency of incident radiation. Incident radiation. So the minimum frequency of incident radiation required to eject the electron, from metal surface, So this is what threshold frequency. We can say it's a threshold frequency. Threshold frequency. So if incident frequency is, incident frequency nu is less than nu naught, then we can say no photoelectron emission. No photoelectron emission. no photoelectron emission. So this is what it's a threshold frequency. Next one is threshold wavelength. Threshold wavelength, it's a lambda naught. It's a lambda naught. So the threshold wavelength is what? It's a minimum frequency, here maximum wavelength. The maximum wavelength, the maximum wavelength of incident radiation, maximum wavelength of incident radiation, of incident radiation. The maximum wavelength of incident radiation is required to eject the electrons, to eject the electrons. So if you write as, if incident wavelength is, if incident wavelength, it's a lambda is greater than lambda naught, then no photo electron emission takes place. No photo electron emission takes place. So this is what threshold wavelength.